Hi guys, you are watching the Top 5 issue, and today we will talk about 5 rare cosmic phenomena. We will find out what secrets they hide and how often we can see this in the sky. Take your seat and let's get started. The 5th place takes meteor shower. It is a celestial event in which a number of meteors are observed to radiate, or originate, from one point in the night sky. These meteors are caused by streams of cosmic debris called meteoroids entering Earth's atmosphere at extremely high speeds on parallel trajectories. Most meteors are smaller than a grain of sand, so almost all of them disintegrate and never hit the Earth's surface. Very intense or unusual meteor showers are known as meteor outbursts and meteor storms, which produce at least 1,000 meteors an hour, most notably from the Leonids. The Meteor Data Center lists over 900 suspected meteor showers, of which about 100 are well established. A meteor shower results from an interaction between a planet, such as Earth, and streams of debris from a comet. Comets can produce debris by water vapor drag, as demonstrated by Fred Whipple in 1951, and by breakup. Whipple envisioned comets as dirty snowballs, made up of rock embedded in ice, orbiting the sun. The ice may be water, methane, ammonia, or other volatiles, alone or in combination. The rock may vary in size from a dust mote to a small boulder. Dust mote-sized solids are orders of magnitude more common than those the size of sand grains, which, in turn, are similarly more common than those the size of pebbles, and so on. When the ice warms and sublimates, the vapor can drag along dust, sand, and pebbles. Each time a comet swings by the sun in its orbit, some of its ice vaporizes, and a certain amount of meteoroids will be shed. The meteoroids spread out along the entire trajectory of the comet to form a meteoroid stream, also known as a dust trail. Next one in our top is a comet. It is an icy, small solar system body that, when passing close to the sun, warms and begins to release gases, a process that is called outgassing. This produces a visible atmosphere or coma, and sometimes also a tail. These phenomena are due to the effects of solar radiation and the solar wind acting upon the nucleus of the comet. Comet nuclei range from a few hundred meters to tens of kilometers across and are composed of loose collections of ice, dust, and small rocky particles. The coma may be up to 15 times Earth's diameter, while the tail may stretch beyond 1 astronomical unit. If sufficiently bright, a comet may be seen from Earth without the aid of a telescope and may subtend an arc of thirditic across the sky. Comets have been observed and recorded since ancient times by many cultures and religions. Comets usually have highly eccentric elliptical orbits, and they have a wide range of orbital periods, ranging from several years to potentially several millions of years. Short-period comets originate in the Kuiper belt or its associated scattered disk, which lie beyond the orbit of Neptune. Long-period comets are thought to originate in the Oort cloud, a spherical cloud of icy bodies extending from outside the Kuiper belt to halfway to the nearest star. Long-period comets are set in motion towards the Sun from the Oort cloud by gravitational perturbations caused by passing stars in the galactic tide. Hyperbolic comets may pass once through the inner solar system before being flung to interstellar space. The appearance of a comet is called an apparition. Comets are distinguished from asteroids by the presence of an extended, gravitationally unbound atmosphere surrounding their central nucleus. This atmosphere has parts termed the coma and the tail. However, extinct comets that have passed close to the Sun many times have lost nearly all of their volatile ices and dust and may come to resemble small asteroids. Asteroids are thought to have a different origin from comets, having formed inside the orbit of Jupiter rather than in the outer solar system. The discovery of main belt comets and active centaur or minor planets has blurred the distinction between asteroids and comets. In the early 21st century, the discovery of some minor bodies with long-period comet orbits, but characteristics of inner solar system asteroids, were called Manx comets. On third place is located Venus crossing the Sun. A transit of Venus across the Sun takes place when the planet Venus passes directly between the Sun and a superior planet, becoming visible against the solar disk. During a transit, Venus can be seen from Earth as a small black dot moving across the face of the Sun. The duration of such transits is usually several hours. A transit is similar to a solar eclipse by the Moon. While the diameter of Venus is more than 3 times that of the Moon, Venus appears smaller and travels more slowly across the face of the Sun because it is much farther away from Earth. Transits of Venus are among the rarest of predictable astronomical phenomena. They occur in a pattern that generally repeats every 243 years, with pairs of transits 8 years apart separated by long gaps of 121.5 years and 105.5 years. The last transit of Venus was on 5 and the 6th of June 2012, and was the last Venus transit of the 21st century. The prior transit took place on the 8th of June 2004. The previous pair of transits were in December 1874 and December 1882. The next transits of Venus will take place on the 11th of December 2117 and the 8th of December 2125. Venus transits are historically of great scientific importance as they were used to gain the first realistic estimates of the size of the solar system. Observations of the 1639 transit provided an estimate of both the size of Venus and the distance between the Sun and the Earth that was more accurate than any other up to that time. Observational data from subsequent predicted transits in 1761 and 1769 further improved the accuracy of this initial estimated distance through the use of the principle of parallax. The 2012 transit provided scientists with a number of other research opportunities, particularly in the refinement of techniques to be used in the search for exoplanets. A parade of planets is an astronomical phenomenon in which a certain number of planets of the solar system are on the same straight line from the Sun with a spread of 20-30 deg. At the same time, they are more or less close to each other in the celestial sphere. The concept of parade of planets is not scientific and is used in astronomy only for its popularization. The maximum convergence of celestial bodies along the ecliptic longitude is called a conjunction, if at the same time they are close enough in ecliptic latitude. In this configuration, it is possible to cover a more distant object with a closer one. The passage of the planet along the disk of the Sun or an eclipse of the Sun. In astronomy, there is no clear criterion for the proximity of planets, so the term parade of planets is of a qualitative nature. It has a stricter meaning in astrology, where the location of planets in the same zodiac constellation is considered to be a convergence. For example, in 2002, 4 planets, Mercury, Venus, Mars, Saturn, met in the constellation Taurus, and the 5th, Jupiter, in the neighboring constellation Gemini, so this parade was not great. Depending on the number of planets participating in the parade, there are small parades and large parades. When 5 planets gather, small parades of planets occur approximately every 20 years. Large ones, much less often. In addition, visible and invisible parades of planets are distinguished. The latter take place if the position of the planets in the sky turns out to be close to the Sun. If we proceed not from the proximity of the planets, but from their exact location on one straight line, then such an event occurs once in many millions of years. And the last phenomenon in our top today is solar eclipse. A solar eclipse occurs when a portion of the Earth is engulfed in a shadow cast by the Moon which fully or partially blocks sunlight. This occurs when the Sun, Moon, and Earth are aligned. Such alignment coincides with a new moon indicating the Moon is closest to the ecliptic plane. In a total eclipse, the disk of the Sun is fully obscured by the Moon. In partial and annular eclipses, only part of the Sun is obscured. If the Moon were in a perfectly circular orbit, a little closer to the Earth, and in the same orbital plane, there would be total solar eclipses every new moon. However, since the Moon's orbit is tilted at more than 5 degrees to the Earth's orbit around the Sun, its shadow usually misses Earth. A solar eclipse can occur only when the Moon is close enough to the ecliptic plane during a new moon. Special conditions must occur for the two events to coincide because the Moon's orbit crosses the ecliptic at its orbital nodes twice every draconic month, 27 days, while a new moon occurs one every synodic month, 29 days. Solar eclipses therefore happen only during eclipse seasons, resulting in at least 2, and up to 5, solar eclipses each year, no more than 2 of which can be total eclipses. Total eclipses are rare because the timing of the new moon within the eclipse season needs to be more exact for an alignment between the observer and the centers of the Sun and Moon. In addition, the elliptical orbit of the Moon often takes it far enough away from Earth that its apparent size is not large enough to block the Sun entirely. Total solar eclipses are rare at any particular location because totality exists only along a narrow path on the Earth's surface traced by the Moon's full shadow or umbra. An eclipse is a natural phenomenon. However, in some ancient and modern cultures, solar eclipses were attributed to supernatural causes or regarded as bad omens. A total solar eclipse can be frightening to people who are unaware of its astronomical explanation, as the Sun seems to disappear during the day and the sky darkens in a matter of minutes. Since looking directly at the Sun can lead to permanent eye damage or blindness, special eye protection or indirect viewing techniques are used when viewing a solar eclipse. It is safe to view only the total phase of a total solar eclipse with the unaided eye and without protection. This practice must be undertaken carefully, though the extreme fading of the solar brightness by a factor of over 100 times in the last minute before totality makes it obvious when totality has begun, and it is for that extreme variation in the view of the solar corona that leads people to travel to the zone of totality. People referred to as eclipse chasers or umbrophiles will travel even to remote locations to observe or witness predicted central solar eclipses. That's all. Thank you for watching this video. Leave your comments, subscribe, and see you later. Goodbye.